Now we will look at inheritance liabilities. First point, may create deep and/or wide hierarchies that are difficult to understand and navigate without class browser tools. Second point, may decrease perform slightly when combined with multiple inheritance and dynamic binding. Third point, without dynamic binding, inheritance has only limited utility. Likewise, dynamic binding is almost totally useless without inheritance. Fourth point, brittle hierarchies which may impose dependencies upon ancestor names. Types of inheritance. Inheritance comes in two forms depending on number of parents a subclass has. First point is single inheritance. Only one parent per derived class. SI requires a small amount of runtime over a head when used with dynamic binding. From an inheritance tree it can be shown. Multiple inheritance. More than one parent per derived class. Compared with SI, MI as additional runtime overhead, also involving dynamic binding. Forms an inheritance directed a cyclic graph. Now we will look at how inheritance is used in C#, how it is used in Java, and how it is used in C++. How inheritance is used in C#. In C#, the specialization relationship is implemented using a principle called inheritance. This is not the only way to implement specialization, but it is the most common and most natural way to implement this relationship. There are two types of inheritance used in C#. They are implementation inheritance and interface inheritance. Now we will look at implementation inheritance. In C#, you create a derived class by adding a colon after the name of the derived class followed by the name of the base class. The derived class inherits all the members of the base class, both members, variables, and methods of the derived class have access to all the public and protected members of the base class. This is an example for implementation inheritance. Bank account is the base class of this code. It has three public members called account name, account balance, and account number. Also, it has two methods called getAccountNumber and setAccountNumber. Then we derive a saving account class from bank account. After deriving the saving account class inherits all the members of the base class, both members, variables, and methods. But if the base class had any private members, those members invisible to the derived class. Information hiding in C# inheritance. Another important thing have in C# inheritance is that it complies with information hiding. Then we consider how it done by the C# language. The derived class is free to implement its own version of a base class method. This is called hiding the base class method and is accomplished by marking the method with the keyword new. Therefore, we can mention inheritance in C# will support the information hiding in the base class. What is the base keyword in C#? When you derive from a class, oftentimes you need to call a method or access field, property, or indexer on the base class from within a method on the derived class. The base keyword exists for this purpose. The first point is call a method on the base class that has been overridden by another method. The second point, specify which base class constructor should be called when creating instance of the derived class. In this example, it has used the base keyword in the doSomething method in the derived class B implementation. It have decided that in my implementation of class B, I want to borrow the doSomething method in class A while implementing the doSomething method in class B. I can call the doSomething method in the class A implementation directly from within the doSomething implementation by going through the base keyword. What is the virtual keyword in C# inheritance? The virtual keyword is used to modify a method, property, indexer or event declaration and allow it to overwritten in a derived class. For an example, this method can be overridden by any class that inherits. Another important thing is by default methods are non-virtual. You cannot override a non-virtual method. Also, you cannot use the virtual modifier with the static, abstract, private or override modifiers. In this example, the class dimensions contains the two coordinates x and y and the area. Virtual method. Different shapes classes such as circle, cylinder and sphere inherit the dimension class and the surface area is calculated for each figure. Each derived class has its own override implementation method called area. Does C# inheritance support abstraction? Subclasses or derived classes are more specialized versions of a class which inherit attributes and behaviors from their parent classes and can introduce their own. In this example, it will inherit all the members and the methods of the base class called bank account in derived class called savings account. This means that the programmer only needs to write the code to them once. Therefore, we can mention in C# inheritance which supports the abstraction principle. Interface inheritance. An interface looks like a class but has no implementation. The only thing it contains are definitions of events, indexes, methods, and or properties. The reason interfaces only provide definition is because they are inherited by a classes and structs which must provide an implementation for each interface member defined. When a class is said to inherit an interface, it means that the class provides an implementation for all the members defined by the interface. The interface itself provides no functionality that a class can inherit in the way that base class functionality can be inherited. However, if a base class implements an interface, the derived class inherits that implementation. Differences between implementation and interface inheritance. A class or struct can inherit more than one interface. We can mention that using a comma between the two interfaces we are going to inherit in derived class. When a class inherits an interface, it inherits only the method names and signatures because the interface itself contains no implementation.